Welcome to the Inside Digital Transformation Podcast. Inside Digital Transformation explores how organizations of every size and shape are using technology today to survive and thrive in the face of relentless change. If you are a business or technology leader charged with making the most of digital transformation in your organization, then this podcast is for you. And now here's your host, Alan Bernard, a technology journalist, editor, and copywriter who has been covering the intersection of business and technology for over 2 decades.
Hi everyone, thanks for tuning in. In today's episode, I'm speaking with Board CTO Nelson Petracek about the different enterprise use cases for distributed ledgers, which most people know as blockchains. We talk about why, despite years of hype, these technologies really haven't taken off. We also talk about some of the alternative technologies, such as immutable databases, that can be used to serve the same purposes, achieve the same ends, but don't come with the same management headaches that distributed ledgers do. And finally, we look ahead to identify where this technology may find a home and if there really are any killer use cases out there for it. Nelson, thank you for being here.
Oh, thanks, Alan. I'm looking forward to this discussion. This has been on the books for a long time.
So I like to start off every episode with the same question, and that is, what is your definition of digital transformation?
For myself, I'm going to take it back to the very stereotypical people process technology triangle that everybody's familiar with, everybody hears. And I think because there's aspects of digital transformation when it comes to how people expect information to be delivered and how they interact with organizations as a result, how they consume information, how they want to receive information, and also how much information they're willing to share, which is an aspect of that, of course, as well.
Okay.
Process is all around, in many cases, as an example, taking manual processes and converting those into some form of a digital process. And in many cases, it's for cost reduction, it's for optimization, it's to build a new capability that maybe wasn't there previously. But there's a lot having to do with processes and how processes can then be transformed to match what people are expecting for products and services. And then finally, of course, you've got the enabler of all of this, which tends to be the technology. This is usually what people talk about. They talk about the advent of cloud. They talk about the advent of, again, IoT. They'll talk about the advent of analytics. Take your pick, but it's really an enabler. It's enabling the digital transformation in terms of how people, again, consume information, receive information, or how they want to share information, engage with the world, if you will, and also the processes that are there to support that. So you have to look at it holistically. It's not just about the technology.
Right. So I have a definition that I run by people, and I'm going to run it by you and see what you think. So my definition of digital transformation is using digital technologies to change the status quo.
Okay. Yeah. I mean, absolutely. If you were to summarize the people process technology element of it, you are changing the status quo for people in terms of, again, how they're interacting with their world, and also the processes that are there to support that. I mean, the processes that we have in place today are often just incapable, insufficient, just not the right processes in order to bring about the way in which information is being processed, handled by people, and so on. So, yeah, definitely you are looking to change the status quo through a digital transformation strategy.
So if you can, without getting too far, into the weeds, can you explain DLT technology? Because I think, there's a lot out there on it. But in the research I've been doing, you're not seeing a ton of page views or a ton of hits on, say, YouTube for the videos that are describing this stuff. So go ahead, if you can, just kind of give an overview of DLTs and we'll go from there.
Sure. Yeah. I mean, from a distributed ledger technology standpoint, it's a capability that's been around for quite some time. And like you said, blockchain is really a layer that has kind of sat on top of it, if you will. It introduces some interesting characteristics into how data is stored, represented, and made more tamper resistant, we'll call it. Not necessarily immutable, but that's a different conversation. Okay. But you are using a distributed ledger to actually store information, distribute information in a particular way. And usually it gets into circumstances where you're trying to share a piece of information across multiple parties. And to do so, you're using a more distributed data structure, in essence, to do that. And so if I have multiple parties that are wanting to come together and get a same view of a certain element or piece of data, one way in which I can achieve that is through a use of a distributed ledger technology. You also have a number of related topics, such as consensus algorithms or different protocols that are used to make sure that if I am distributing data across this ledger, if you will, that everybody eventually gets it and they all have the same view of it. So how do I ensure that that's going to happen in the case where a node may be down for a certain period of time? Or you might actually have a malicious actor that is not necessarily acting in the best interests of that multi-party data exchange. And so how do I try and prevent that from impacting my data negatively, obviously? So that it's distributed. It's a way to take data, distribute it across multiple participants, and do so in a way that is tamper resistant in many cases if you introduce capabilities such as blockchain on top of that, and then also do so in a way that's reliable. You eventually will have the same view of data, and then you try and scale that out across many nodes as you can.
But all DLTs, so they share the same structure where each participant in the network, right, holds a complete copy of all of the data in that distributed ledger, correct? And that's what gives it, that's what engenders the trust, right? Because if you change, one node cannot be changed without changing all the other nodes. Everyone holds a copy of all of the information in each of the nodes. So therefore, they can see their version of the node as the trusted version, and they don't have to rely on a clearinghouse, which is basically the systems that we have today. Can you explain that a little bit?
Yeah, I mean, the ledger is going to work in conjunction with the consensus algorithm, which again is responsible for making sure that everybody gets the data that they're supposed to be getting, even in the event of some form of let's say, infrastructure failure. So there's elements like you'll hear about Paxos, you hear about Raft, you'll hear about these different protocols that really facilitate that distribution of data to all the nodes. So you're right. Everybody will have a snapshot, if you will, of that data on that node, and everybody in theory should have that exact same snapshot. Now,
there you go. Right.
There's the element of if you start to layer blockchain on top of this, now you're starting to create a chain of data where there's the way in which the data is linked is done cryptographically, such that if somebody tried to change a piece of data in the middle, if you will, of your chain, that's when I'm going to be able to detect that, because now the cryptographic hashes that I'm using to build this linked structure no longer hold true. And so I can detect the fact that somebody has tried to tamper with a piece of data, and subsequently I can effectively know that, okay, that data is not what I think it should be. And as a result, the consensus algorithm along with the blockchain data structure work together to be able to facilitate, again, the identification of somebody going in and changing data that I'm not expecting to be changed.
Right.
So
and in the blockchain, it's a series of blocks chained together, right? Hence the name. And each block holds, I think, minimum at least a megabyte of data of all types, could be anything in there, right? And then that is mined. The miners create the hash to validate that data, right? Which then is assigned to that block, and then the block is assigned to the chain. And then each new block in the chain carries the hashes of all the other blocks that came before it, correct? And so that if if data is changed within a block that's in the chain, its hash is automatically changed. And then that ripples through the entire blockchain, right? And that's what makes it so difficult, because if you change a block in the middle of a very large blockchain, you have to have the computing power to change all of the hashes that come after it in order to hide your tracks, right? Which makes it kind of immutable, right? But to your point, almost immutable. Okay. Am I on track here?
I mean, because that's one form. So again, going back to the discussion around the distinction between the actual way in which the data is stored and distributed, which is now more of the ledger, than the blockchain data structure, which to your point is using the hashes as a way to link the blocks together. And then you introduce the consensus algorithm that then says, in your case, you're describing or alluding to proof of work, which is where in the Bitcoin network, for example, you do have miners, which are really going through a mathematical guessing game, if you will. They're trying to compute some number, and then the first one to do so then wins the prize, and the prize is the ability to actually add that block to the chain. And then in the meantime, all the other miners are gathering transactions. They're trying to create these blocks. They're trying to guess this number, and all working together to try and build this chain. Now, that's proof of work, but there's other types of consensus algorithms that are deployed and utilized in different types of blockchain networks. So you may have, for example, proof of stake, which would be a different mechanism that's used in order to try and ensure that the information that's being added to the blockchain is the information that you expect it to be. In the crypto space, you're trying to avoid things like the double spending problem. So people spending money crypto that they effectively don't have. In other cases, you're trying to make sure that the data that is being added to the chain has been validated, let's say, through a different type of consensus algorithm. So
and there's
all
a
of that
bunch
has
of
to
them.
work together.
And there's new ones coming out too that use like 99% less power.
There's a huge list. There's a huge list of these things. I mean, there's literally dozens, if not even 100 of these things that are floating around out there.
But the goal of all of them is to validate the information going into the DLT, the distributed ledger, right?
That's right.
We'll call it a distributed ledger,
Yeah.
right? So explain the nuance between a blockchain and a distributed ledger. There sounds like there's a separation of state here that we need to establish.
Yeah, there is a separation. So the blockchain is really adding the link that you were describing earlier. So there with the cryptographic hashing. So the distributed, it's built on top of, or it's one form of a distributed ledger when you talk about blockchain. And blockchain is creating that link, because I can use a distributed ledger without that and just use it as a way to distribute data across multiple participants or nodes. And I don't necessarily have to have the blockchain data structure, that cryptographic hashing where things are linked to the previous block. I don't necessarily need to have that.
Okay, so you and I could set up a distributed ledger between you and me, and it would be two nodes. It would be my computer, your computer. If we agree on a data sharing agreement, maybe write some scripts to do that sharing between databases, we have a distributed ledger. Right. Now expand that to 1,000 nodes, 100,000 nodes, whatever it is, and now you have the capacity to do things differently in the world than the way they're being done today, which is primarily through, again, clearinghouses, right? Which serve that same function to validate data, engender trust that the data is valid and that you can trust it. Well, that's kind of repeating myself there a couple times.
No, it makes sense.
But I mean, but that's the point, right? Is that's the clearinghouse function, but that adds a lot of time, process, and expense to say international shipping or something like that. Or, I read somewhere that, small businesses have a hard time entering international markets because of getting that clearinghouse to accept them as clients, for example. I think is where if you had a blockchain or a DLT type situation, they could use that to exchange money. They could exchange contracts. They could exchange their bona fides.
Yeah, I mean, one of the arguments that you will typically hear around why one would want to use blockchain is the quote unquote elimination of the third party. Now, and this is the clearinghouse that you're referring to, right? Where you are trying to exchange transactions without having to go through an intermediary. And so the idea is that, yes, it cuts down on, let's say, the amount of time that it would take to actually clear that transaction. It would eliminate any potential for additional malicious actions, if you will, by that third party. So there's this argument around being able to streamline the way in which people can exchange information and conduct transactions by eliminating that third party. But in many cases, though, you cannot eliminate third parties completely. And even when you look at, let's say, some consortiums that have been created around different blockchain networks. So let's say there's a consortium around supply chain. So a number of participants get together and they say, we want to exchange information in a much more streamlined fashion. Let's create a consortium. And that way there's no third party and all the information can flow freely. The problem with that is that there typically is a third party. The third party is actually the governing body that's managing the consortium itself. So, because at some point you have things like, well, what happens if there's a disagreement across different parties? How do I resolve that disagreement? How do I set the rules and the guidelines and the standards and the regulatory requirements and all those things that are required for that consortium to operate? Who's doing all of that? And so typically you then run into the instantiation of a third party, which is the governing body around the blockchain network. So in that case, is it true that there's no third party, or has the third party just taken on a different form? And so this is why in many cases, blockchain as a technology, it had a lot of promise and hype, but in reality, a lot of the use cases that it was being applied to ran into challenges, and the challenges weren't necessarily related to technology. They related to things like, how do I create this consortium? And from a legal standpoint, how do I even get all these parties to agree? That was hard enough, never mind actually implement the technology.
Interesting. So is the technology fairly bulletproof? I mean, meaning it works, right?
Well, so that there's also it depends. If you, it's hard to go through a week without reading about some hack somewhere.
But that's different than the technology actually being functional, right?
True. Well,
secure versus functional, right?
That would be true. Now, the argument there would be, for example, a lot of blockchain technologies allow you to write what are called smart contracts.
I was going to get to that,
right? Which are business logic that you're going to embed in the blockchain network. Now, is the fact that you're able to write a bad smart contract, does that mean the technology works or not? It's running as compiled or designed or whatnot.
Right.
But
let's define what a smart contract is first.
It's code. So I am going to write a bunch of code using whatever the
about what though? Code that describes what?
So code would be it's the business logic around the transactions that are being executed across the network.
So again, you and I want to do some business together. We're going to use a smart contract in lieu of a bunch of paper and lawyers and other things, right?
Exactly.
Okay.
Yeah. That smart contract will respond to the submission of a transaction. So I will submit a transaction to you, and maybe I am submitting some sort of a intent to purchase a good or service from you. Mm-hmm. And you are going to, at some point, fulfill that delivery of a good or service, which then is another event, if you will, that acts upon that transaction. That smart contract will then say, okay, here's the contract, that the agreement that's in place. It's on the blockchain network. Everybody can see it. It's transparent. So the world, if you will, in that network knows that we're engaging in a transaction. And then at some point you fulfill your side of the bargain, if you will. Mm-hmm. And then that smart contract, knowing that, will then release the funds, let's say, to you, right? Knowing that you've fulfilled your part of the bargain, as represented by the smart contract. I've fulfilled my side of the bargain. The transaction is complete. Everybody can see that. It's recorded on the ledger. And now if I need to go back, let's say, and validate that because there's a dispute 6 months later, I can go to the ledger and in theory, point to the fact that, no, you know what, this transaction did occur. Here's the record of it. Everybody agreed upon it. The network agreed upon it. So that transaction, it should be true. You have no, dispute here is one way to kind of look at this. So that would be one example of how that interaction would occur.
It's pretty complicated, right? So to me, that seems like a stumbling block. Is that part of the issue why, DLTs haven't taken off in the way that, say, 5 years ago, people were saying they would?
Yeah, I think initially you saw a lot of hype around the technology, as you do with a lot of emerging technologies, if you will. I think that people then tried to throw blockchain at everything, thinking that it would solve all the process problems, all the people problems. It would completely alter the status quo, as you referred to at the very beginning of the conversation. And people quickly found out a couple different things. One is, to your point, the technology itself is not easy. How do you manage a completely distributed, decentralized environment? How do you upgrade it? How do you even monitor it? How do you upgrade your smart contracts such that everybody agrees?
That's what I was wondering. How do you upgrade the business logic in your smart contract?
So it's complicated because now you're not only trying to coordinate all the parties within your own organization, but you're trying to coordinate all the parties across multiple organizations. So that became complicated. And I think that people, to do a proof of concept with 2 nodes and exchange transactions between those 2 nodes, that was easy. To create a consortium with multiple parties, different organizations, geographic distribution, different, sometimes regulatory bodies,
currency exchange rates,
exchange rates, and all these things, it quickly became complicated.
Sanctions today is a big deal, right?
Yep, exactly. So all those, then I think people realized that, yes, while the POC was easy, the enterprise use cases, I'm gonna make sure we point out the fact that we're talking a lot about enterprise use cases here and staying away from crypto for the moment. But
totally.
A lot of the enterprise use cases, then people looked at them and said, well, quite frankly, a lot of these I can achieve by using a database in one of the hyperscalers. And even the hyperscalers will offer some form of a ledger technology on top of a data store such that I can prove that the data hasn't been changed. And then that's all I really need. And if it's centralized, I trust AWS or Microsoft or wherever the hyperscaler happens to be. And I'm fine with that, right? I get that single view that everybody can access, multiple parties, without the complexity associated with the decentralization and distribution of what a distributed ledger blockchain would bring. So,
right. And so that's the permissioned versus the permissionless versions, right? Because I think that might be important to bring up, where I think Bitcoin is a permissionless distributed ledger, where what we're talking about for an enterprise use case would be a permissioned distributed ledger, where you have 15 companies that are working together, they set up a blockchain between them, right? And then you have to ask for entry. You just can't access that blockchain, right? Can you kind of talk about that for a minute?
Yeah, that's definitely how a lot of the proof of concepts, use cases, things like that started. Organizations tended to initially shy away from the permissionless world because they were concerned about things like security. And so what they would do is they would form a kind of a permissioned, as you mentioned, consortium blockchain, where the only participants were the people that they knew, right? The organizations that they knew about, as long as it was set up correctly and was secure. But that was the idea. So they would create their own little group, if you will, and use blockchain in theory as the mechanism by which to distribute data and execute business logic across that group. Now what you're finding is that world has been changing. So as you get more blending of the permissioned and permissionless worlds.
Oh, great. So now we have hybrid.
Now you have hybrid.
Okay.
Yeah. And some blockchain networks allow you to create hybrids where some of the networks, if you will, are permissioned, but they all have the ability to share certain types of information across permission networks. And so you're now getting, into a little more of this hybrid mode of operation, much like in cloud.
Right, exactly.
On-prem to cloud. It's like, but on-prem's not going away anytime soon. So let's create a hybrid. In this particular case, people are now looking at blends. And this is really because of decentralized finance and a lot of the hype, if you will, that there was around cryptocurrencies, maybe not so much now, also around even the exchange of different types of transactions, the fact that these permissionless networks are already there. I don't have to stand one up myself. And the technology is also evolving to support different security and privacy capabilities. And then organizations are now starting to take a deeper look at that. So they're not as shy in terms of how, looking at permissionless networks as they maybe were a handful of years ago.
Okay. But again, where there's existing technologies, like you say in the hyperscaler, what are those databases called, by the way, the immutable ones that I could get?
They'll, generally speaking, I might refer to them, I think the general term would just be like a ledger database. So
got it. Okay.
Good for things like auditability. If I need to prove that this is the way the data was for regulatory purposes or whatever, this is a potentially one way to do so.
Okay. Well, that's a nice transition into use cases then. Where are distributed ledgers being used today to good effect?
Right. So finance is going to be the first obvious set of use cases. I mean, a lot of banks, a lot of financial institutions, organizations that are related to those banks and financial institutions, they are looking at the use of blockchain technology for...
But are they using it today, or they're just still exploring, just kicking the tires?
Both. There'd be both.
Okay.
There are implementations today that are sitting on top of blockchain technology, but there's also a lot of research that's being done by those kinds of organizations. And when you look at it, so as an example, you would have heard a lot around decentralized finance. So trying to create financial products that are not owned or controlled by a central organization. So if I, as an individual, want to get a loan, I don't have to talk to the bank, if you will. I can actually go to a decentralized finance or a network that supports decentralized finance. And that loan, for example, would be implemented as a smart contract. And that network is going to bring together kind of borrowers and people that are then providing money into a pool that can then be provided to those borrowers. And all that is managed and controlled by, again, smart contract. The goal here is to provide financial products, instruments, capabilities to people that ordinarily may not even have access to those products and capabilities.
Okay.
And it's much easier for me to just have an internet connection and some sort of an application on my phone, and I can now participate in finance. And it doesn't even need to be fiat. It can be some other form of token that I can now use as a form of, quote unquote, money, if you will. But I can use that as my form of exchange for goods and services. And I can do so in a way that's much more open, much more transparent, and not controlled by any one authority, whether it's government or whether it's a bank or whoever. So that was the promise of decentralized finance. Now, that didn't hold true in all cases, but that is a use case that I think will continue to evolve.
So if I go apply for a loan through that network, and it may again have an app, right? Probably as a front end that looks pretty user friendly, but the back end is the distributed ledger, right? That is actually functioning, and then smart contracts that are actually running it. So that therefore doesn't have to go through a loan processor. You don't have to have paper printed out somewhere. You're not seeing green screens at a bank where somebody's looking through a bunch of numbers on a database saying, okay, you have the loan. The network itself makes the decision, right?
Right. Yep. The code is there. And I mean, the network is also bringing together all the parties that want to participate in that transaction. So, I mean, if I'm investing, let's say, or if if I'm taking out that loan, well, those tokens, that crypto had to come from somewhere. And so you've got people that are injecting money into the system and hopes of some sort of return. And then people that are using that money for, or I keep saying money, but it's the loose definition of money in this case. Not
yeah. And tokens are interesting. Tokens are interesting because you can tokenize anything. It seems like, right? We were talking about this before. It's just basically taking the stock model of business in the business world and applying it to an apartment building or a sailboat or a plot of land or.
Sure. But to your point, there's also a lot of opportunity, because now what you're doing is you're introducing programmability to assets that ordinarily would not have programmability associated with them. So you could have, for example, a big piece of equipment. Now I can have that piece of equipment be represented in a program, smart contract, and that lends into even things like then fractional ownership in that piece of equipment.
Right.
So now I've increased liquidity as it pertains to that piece of equipment because it's all represented as a token. Now you need the rules and validation checks, right? Does the token actually represent that piece of equipment? Is that piece of equipment actually in a usable state? Did somebody break it? So all those kinds of things need to be addressed.
So how does then how does applying a blockchain or distributed ledger to that existing business model make that existing business model better?
I think people are still, quite frankly, hunting for that killer use case. And this is maybe one of the reasons why it kind of goes through these cycles, right? We've had this hype around, everything was going to be blockchain, and that kind of died off. And then we saw the DeFi hype cycle. And then now, obviously you hear less about that. And I think there will be a few more of these cycles as people try and figure out what is that killer use case. And so people right now are trying a lot of different use cases. So your voting example, there'll be the flip side of that will be people will say, voting, that is not a good use case for blockchain, or even for dealing with healthcare and let's say private information. So, or even GDPR requirements, the right to be forgotten. How do you implement that if you're actually using a blockchain network who's designed to not actually forget or lose or allow you to delete even? So there's these kinds of considerations that come into play. Now, there are characteristics that point to blockchain being a better potential solution than, let's say, other types of solutions. So, for example, you're looking at the degree of decentralization that's required, potentially the degree of things like the level of transparency that's required. You're looking at things like the level of programmability, transparent programmability that's required in the network. You'll be looking at the number of participants that are involved, elements of trust, right? Where and how are you going to incorporate trust into the network? So there's going to be all these different factors that need to be looked at when trying to determine whether or not blockchain is going to be a good fit. And that's why, again, it's been evolving. It's been looked at in the context of these different use cases. Another use case that people are looking at in the context of is the whole metaverse that you often will hear about.
Right.
Now, is blockchain mandatory for the metaverse? That'll be an interesting kind of conversation to have with the next handful of years, because in some ways it's not. But Is it a potential mechanism for tokenizing assets in the metaverse, sharing assets even across metaverse or worlds that exist in the metaverse?
Executing transactions.
Yeah, carrying an asset from one world to another. Is there a way that a blockchain could facilitate that type of interaction? And so, that is going to have to evolve. People don't have all those answers yet, but those characteristics are really what one has to look at. Even performance would be another good example. Blockchain networks are not necessarily known to be blindingly fast.
Right.
So those are the kinds of things you need to look at when trying to determine whether or not blockchain is appropriate for your use case.
So what is it about blockchain that makes it so useful in so many different use cases?
Right. I think a large part of it has to do that the world is becoming more distributed. There's many more interactions between parties, and people are looking to build, in essence, decentralized business networks. If I'm looking at it from an enterprise standpoint, I am engaging with more parties, more partners, more participants. I'm doing so on a much more frequent basis, and I need to do so in a way that's transparent and secure. And I think those kinds of use cases are what are driving a lot of the interest in blockchain.
What is an ideal use case for blockchain?
That's going to be a good question from an enterprise standpoint. Any scenario. The decentralized finance use cases, I think, are going to be ones that you're going to continue to see a lot of. I'm going to go with that as kind of the starting point, simply because there are a lot of people that just quite simply don't have access to those kinds of products. And if we can make it easier for more people to have that type of access to those capabilities, I think, generally speaking, you present a lot of opportunity. If I can bring more of those financial capabilities to people that previously did not have access to them, that's a huge enabler.
And we're talking about basic stuff, savings accounts.
Exactly.
Right?
Savings accounts,
banking.
Just getting a loan, being able to open a small business and actually operate that small business.
Line of credit.
And these are, we're talking about banking products, of which there will be decentralized financial equivalents. But there's also new types of financial assets that can quickly and easily be created. Kind of composite. You take all these different sort of assets and put them together into new financial assets that can be of value to individuals. It's a lot easier to do that.
But, another one I just thought about was this bill of materials and traceability and provenance when it comes to IoT. Right. And that's an issue, right? Where did the parts that make my products come from? Right. Yep. And blockchain seems like a good use case for that.
Yeah, that was and to many levels still remains one of the key enterprise use cases for blockchain that most people will look at. So chain of custody, product provenance. Chain of custody.
There you go.
Yeah, definitely. And because a lot of people have, for example, have definite interest in making sure that the goods that they're purchasing are not counterfeit, and also where things came from. So where did that grocery item come from, and can I track all the main steps in terms of how it was handled and who handled it along the way, the entire supply chain. And blockchain is one way that you can then facilitate the capturing, sharing, distribution of that information and achieve some level of auditability for regulatory compliance. Right. And as a result, or even if if a part ends up within a part, which ends up within a part, which ends up within a part, and then eventually I need to go back and try and do some sort of trace to find out what defective part and where it went, and those kinds of things. Maybe if I can use a blockchain network to track all the ownership transitions that occurred, I have a complete history and record of that, even across multiple parties. So then I could go back and say, yeah, that part is defective. We need to swap it out. Otherwise, it's going to blow up or whatever it is. So those kinds of use cases, this traceability, product provenance, chain of custody, those were the very stereotypical use cases in the enterprise for blockchain.
Okay. All right. Well, covered a lot of ground here. At the end of the day, it seems like it's a good technology. I don't know. How do you wrap it up? I mean, the technology works. People process is a tripping point. To me, the big stumbling block seems to be that you're trying to replace what's already being done with something that that maybe isn't any better ultimately.
Yeah, I mean, if that's the use case, then that's may not be the use case for you. Like there's a number of use cases where blockchain was implemented, but the improvement was purely related to the fact that they've eliminated paper. It wasn't because of the fact that they introduced blockchain. So, but as an individual that deals a lot with technology as it pertains to its use within an enterprise,
right?
My general advice, and this is going to be true with any type of technology, this is not unique to blockchain, but generally speaking, it is a technology that you need to be aware of. You need to know what's happening in the space. You need to watch for those use cases where it could be applicable. And I always recommend that people try it. Even if the use case is not valid, at a POC level, it doesn't matter. You're going to learn a lot. And you're going to learn a lot about the technology. You're going to learn a lot about how you would even need to organize yourself internally to support such a technology. And you will learn what use cases are applicable and which ones are potentially not.
All right. So Nelson, thank you very much. This has been a great call.
No, thank you. I've really enjoyed it. Yeah, we covered a lot of ground. Absolutely, as you mentioned. So, hopefully that's good for our listeners.
If you like this episode, please tell your friends and subscribe. We post new episodes every week. If you'd like to join our mailing list, become a guest, or suggest topics for future episodes, you can find us on LinkedIn, on our landing page at anchor.fm/InsideDT, or at InsideDT.net. Talk to you soon.